Okay, hello again, ladies and gentlemen. All right, I'm going to go over your questions on the cross sections and rotations ditto. Okay, a lot of you had the same questions. Um, so I'm going to start off with number 6. Okay, a rectangle whose length and width are 10 and 6, just like in the diagram, okay, is shown below. The rectangle is continuously rotated around a straight line to form an object whose volume is 150 pi. Okay, and it says which line could it be being rotated around, and it gives you the 4 choices. So basically what we have to do is figure out the volume of the cylinder that is created when that figure is rotated around each of those given lines. Okay, so we're going to find the volume each time and see which one ends up to be 150 pi. Okay, so 150 pi is the goal. All right, so I'm going to switch to some other paper here just to kind of because this is going to take a little bit of work. Okay, so choice 1 says if we rotate it around the long side. Okay, so if I rotate this figure around this long side, which is 10, I get a cylinder that's going to look like this. Okay, that's going to be my cylinder. Okay, it's going to have a radius of 6 and a height of 10. Okay, so the volume is going to be pi r squared h. Okay, that's the area of the base times the height. Okay, which is going to be pi. My radius was 6, so r squared is 36 times the height, which is 10. That's going to give me 360 pi for the volume. Remember, what I'm trying to get is I'm trying to find out which one is 150 pi. So that's out. Okay. Second choice says if I rotate it around a short side, that means I'm going to rotate it around this side right here. If I rotate this rectangle around that side, I'm going to get a cylinder that kind of looks like this. Okay, which is going to have now the radius is going to be 10 and the height is going to be 6. So that's going to be volume equals pi. The radius is 10. 10 squared is 100. And the height is 6. That's going to give me a cylinder with a volume of 600 pi. Okay, so that's no good. All right, so I'm going to keep going. Number 3 says, suppose I want to rotate this rectangle around a vertical line of symmetry. The vertical line of symmetry is right here. Okay, so if I rotate that around that line, I'm going to get a cylinder that looks like this. Okay, it's going to have a radius of 5 and a height of 6. Okay, so that volume is going to be pi r squared, which is 5 squared is 25. Okay, and then pi r squared, and then times the height is 6. That is where I'm going to get 150 pi. So that's how we get that answer. Okay, if we go on to number 4, okay, if I were to rotate this around a horizontal line of symmetry like that, okay, I would get a cylinder that looks like this. Okay, its radius would be 3 and its height would be 10. So volume equals pi r squared h. Okay, the radius would be 3, squared would be 9. So this would be pi times 9 times 10. That would be 90 pi. That would give me a cylinder with a volume of 90 pi. So that's how we get our answer of 3. Okay, so we're checking what would be the volume of each cylinder that would be created by rotating it around each of those lines. Okay, so hopefully that clears that one up. Okay, the next question that people had asked was number 8. Okay, circle O is centered at the origin. Okay, the diagram, only a quarter of it is shown, okay, is graphed. Okay, what three-dimensional figure is generated when the quarter is continuously rotated about the y-axis? So I'm going to take this and I'm going to rotate it around the y-axis. I'm going to get if I continue to rotate, I'm going to get this figure, okay, which is going to be half of a sphere. If you imagine rotating that around, it's going to kind of, if it was the whole thing, I would be getting the whole sphere. Okay, but it's only a quarter, so I'm only going to get this bottom half of that sphere is going to be is going to be the figure that comes out, the hemisphere. Okay. Number 10 is exactly the same as number 6. Okay, so I won't go through that one again. Okay, and then the last one, okay, two-dimensional cross-section is taken of a three-dimensional object. Okay, that means we're slicing it through, just like some of the other questions on this packet, on this ditto and the other one. Okay, this cross-section is a triangle, which cannot be the three-dimensional object. Well, we know if we slice a cone vertically through its vertex, okay, if we look over here, if I slice number 11, if I slice this thing vertically through its vertex, let's see if I can draw this, kind of like that, okay, that cross section is going to be a triangle, okay. A cylinder, okay, that's going to be your answer. There's no way to cut a cylinder and get a triangle. If I cut it this way, I get a rectangle. If I cut it this way, I get a circle. If I cut it this way, I get an ellipse. Okay, so I'm not going to, so cylinder is going to be my answer. Okay, pyramid, clearly if I cut that, again, the same way I cut the cone through the vertex, I'm going to get a triangle. Now, a rectangular prism, that might be the one that's not quite clear. If I look up at this rectangular prism, and I'm number 11, and I cut just a corner off, like suppose I take a cross section just like that. I just cut that corner off. Okay, try and imagine what figure would be facing you. Okay, you know, what would be left, or if you took off that slice and looked at it, it would be in the shape of a triangle. Okay, so the only one that does not result in a triangle ever would be cutting a cylinder. Okay, so that's why 12 is number 2. All right, so that was it. Hopefully that cleared everything up. All right, we'll see you next time.